All right, now this is a trapezoidal prism. So here we have these bases are trapezoids, and it has a height of 5, because essentially you're multiplying the area by the base. You're multiplying the area of the base by the height, because essentially you're stacking them on top of each other. That's how many you have. So here it's showing, all right, it's right here is 14. This is 6, because it's the same as here. The height is 3. So first, we want to find the area of the trapezoid. Now this is base 1, and that's base 2. We did area of trapezoids in a previous section of this chapter. So the area of a trapezoid is 1/2 is the average of the bases, so base 1 plus base 2 divided by 2 times the height of the trapezoid. So here we have 1/2 6 plus 14 times the height of the trapezoid is right here is 3. So 6 plus 14 is 20. Divided by 2 is 10, times 3 is 30. So the area of the trapezoid is 30 centimeters squared, but remember volume is the area times the height. So the volume is going to be 30 times the height is 5. So remember, those heights are different. We have the height of the trapezoid, and then we have the height of the actual prism. So you want to keep in mind which one you're doing at a time. So 30 times 5 is 150. We're actually still in centimeters like the last one. 150 centimeters squared. And then this one is a pentagonal prism. So here's our base, and that's a height of 6. So the area of a regular polygon, which is what we did in 11.3, is 1/2 the apothem times the number of sides times the side length. So here they gave us the apothem. So the area of that base is 1/2. The apothem is 2.8. Number of sides, it's a pentagon, 5. And the side length is 4. So 2.8 times 5 times 4. Half of that, that's 28 exactly. So the area of that base is 28. And then essentially there's 6 of them. That's the height. It's kind of them stacked on top of each other. So the volume is going to be 28 times 6, which is 168. And this time it's meters, so we're doing meters cubed. All right. We're going to do some cylinders now. So cylinders, it's the same. It's the volume of the base times the height. Now the base is just a circle. So from the last, from 11.2, the area of a circle is pi r squared. So the area of that circle is going to be pi 9 squared, or 81 pi. If you remember, I like to put the pi in at the very end, so I'm doing as few decimals as I can. So the volume here is the area times the height. So I have 81 pi, and the height here is 6. So I put 81 times 6 times, again, you can use 3.14. I like to use the actual pi button, and that gives us 1526.81, and it's going to be feet cubed. This is called an oblique cylinder. It's kind of tilted on its side, but it actually stays consistent. So it doesn't actually matter. It doesn't change. It's still, the volume is still the area of that circle times the height. So here the area of that circle, pi r squared, r is 4. It's the same in both places. Times the height is 7. So I have 16 pi times 7. Put that in our calculator. We get 351.86 centimeters cubed. Lastly, we can find a missing piece. So here I have a chest. I have 2 of the measurements. I'm missing one, and I have the volume. So the volume is just length times width times height, because essentially length and width are what's going to give you that base. Length and width is what's going to give you that base, and then you're multiplying it by the height. So our length is 6, our width is 4, and our volume is 72. So we have 72 equals 6 times 4 times height, because I want the height. So 72 equals 24h. Divide both sides by 24, and you get 3. Keep in mind, you want your units to be correct. So the volume is cubic feet, because essentially this is feet times feet times feet. All right, now go and watch 11.5 part 2.